you remember where we left off on Wednesday, we are talking about interrupts. So interrupts are the ability of your processor to respond to different events, respond to different inputs. And the idea is that you use an interrupt because your processor is out there doing something else that it cares about, waiting for some event to occur, and it then wakes up from whatever it's doing to service your task. When you're doing assignment 2, the difference in this is where in task 1 you're sitting there waiting for the timer, waiting for the timer, waiting for the timer. That's a waste of time because your processor can be doing other stuff or it can be going to sleep and save energy. The way that you want to use interrupts is the way that you did at the end of assignment 2 where you say, hey, I'm going to set up this timer to go off after a second. After that second, then I'll come back and I'll deal with the activity. So remember, interrupts move from inactive to pending when they are triggered to active when they get serviced. An interrupt has to be enabled and pending to become active and be serviced. And interrupts have priority such that if there are 2 interrupts occurring at the same time, the one with the higher priority goes first. Your interrupts are stored in a table in memory, and that table contains the addresses of the interrupt vectors. Sidebar, do we want that camera to stare at the screen the whole time, or do you want it to follow me, for those of you that have been watching the video? Does anyone care? We'll just have to stare at the screen. We talked about interrupts generally. The interrupts on this particular system. There are 16 possible interrupts that can happen on your giant gecko. They're referred to as ENT 15 through 0. So there are 15 possible interrupt sources on your giant gecko. For those 16 sources, though, there are only 2 interrupt handlers. So with the timer, you can trigger on underflow, overflow, some sort of capture, and would call the timer 0 interrupt. Here, for all of the GPIO, there are 16 possible interrupt pins that are configurable, but they will only call 2 interrupt handlers. The interrupt handlers are called even and odd. So if you have an interrupt set for an even numbered pin and it occurs, the even handler gets called. If you have it set for an odd interrupt handler and it occurs, the odd interrupt occurs. For our purposes here, 0 is an even number. The main registers that you use are called this exit P cell and exit P cell H. It's a weird naming. It's an external interrupt, select low, external interrupt select high. So there's 2 high. Again, you've got a high register and a low register that are governing which interrupts get tied to which pins. Now, one funky thing is that interrupt 15 is tied to all pins numbered 15. So you don't get a free choice of how your interrupts are assigned. So interrupt 0 can be triggered by PA0, PB0, PC0, and so on and so on. So every interrupt of a certain number is tied to one of the particular pins of that number. What that means is that if you tie PB5 to an interrupt, you cannot tie PC5 to another interrupt because they all get mapped to the same thing. So the choice that you have is you're not necessarily picking the pin because the interrupt is already tied to a set of pins. You're picking which port it comes from. So interrupt 7 is tied to all of these 7 pins. You've got to pick whether it's going to come from A7, B7, C7, D7, and so on. So it's a little quirky and it's kind of hard to get your mind around, but that's the way that it's set up. So the interrupt number tied to the pin number, you are selecting the port. And the way that that looks inside this register is that here is the select low register. And let's say that you're trying to select, we'll do here with 7. Let's say that you're trying to pick, you want to use interrupt number 7. If you're using interrupt number 7, your choices are not 5, 6, and 7. Your choices are A, B, C, D, E, F. So if you put the value 1 here, if you put the value 1 in external interrupt 7, that means you are selecting PB7 as that source for that interrupt. So it gets a little confusing when you try to set up the interrupts because you pick the interrupt based upon the port, not necessarily the pin number. If you want to look at this graphically, this is the entire chain from the pin sources to triggering the interrupts on the processor. So these select registers pick for you which port it's going to come from. So if this is interrupt 0, you're going to pick either PA0, PB0, PC0, and so on. After you've selected the port that you want and you've routed the pin over there, you get to pick whether you want to detect rising edge or falling edge inputs. This is in relation to the interrupt number. So if you're working with interrupt 0, you're going to modify bit 0 of these registers to either enable rising or falling edge. So what you can see here is a little edge detector block, the register, which is going to have the enable bit, and an AND gate. So think back to sort of digital circuits. Think logically that my pin is going to come through here. There's going to be an edge detection. If that edge occurs and that bit is enabled, it goes to this OR gate that then goes down the chain and it sets up the flag. So here is where the interrupt flag will get set. Remember, for an interrupt, even if this event occurs, it has to be enabled. So not only does the event have to occur, I have to also have the interrupt bit enabled. That's what this AND gate is here for. And it collects all the interrupts from all the pins and either triggers even or odd. So to understand how interrupts work, you need to understand and explain this diagram. Like, you should be able to tell me what's the purpose of sort of each of these registers. Now that I think of it, it sounds like a pretty good exam question of explaining to me what each little block does. So, for example, this mux right here is selecting which port you want to pick for this interrupt. These AND gates and these edge detectors are figuring out whether you want to detect a rising edge or a falling edge for the interrupt. These guys down here on the end are dealing with whether the interrupt is enabled, setting the flag, and then sending all of the interrupts to the processor. Questions on this? We're going to make it concrete in a second by picking up how to select particular things for a particular interrupt. So, take a second, look at section 32.3.5. Tell me what registers and what fields you need to set to enable interrupts. So what stuff, so read that little section that describes the functionality, look up the various registers, and tell me what you need to do if you were going to set up interrupts. There are 4 major things that we're looking for. The only external interrupt that PD0 can actually be tied to. So if it's PB0, the only interrupt it can be associated with is external interrupt 0. That's the only one it can be associated with. So this is associated with ENT0. Right? Let's see. Ben, if I wanted to enable this, what registers do I need to modify to enable that external interrupt and select port B? So to enable this interrupt, what you've got to do, the first thing is you have to modify the select register low, and you need to enable port B as the ENT source. So if you look back at our diagram here, The first thing in this step is I've got to modify this select register. And if I want to do PB0, I've got to modify this register here and select port B for that interrupt. So if once I select port B, as Michael said, I don't have to come here and modify the rising edge to get bit 0 and enable the rising edge. Then I've got two other things. So looking on this diagram, what are two other things that I have to do, that I have to set to get my interrupts all the way out? Ben. All right, I got to do the interrupt enable. So Ben, is this register here inside my peripheral or inside my processor? You good choice. You had a 50-50 shot. These are the lines going to the processor. This is the interrupt enable inside of the peripheral. So when you say interrupt enable, I want to make sure that we all know that it is in the peripheral that you have to enable. So you have to pick which pin you want. You've got to pick which port you want. You've got to set that you want it to be rising, and then you want to enable interrupt in the peripheral. Ben, yeah.
This would be like, before it was like timer 0 with the arrow and then IN.
Yeah.
GPIO.
Yeah, they're all going to be. So this common stuff. These are the actual names of the registers. So yes, this would be GPIO, and then the GPIO is different because you have the P with like the port number. But it'd be GPIO. Actually, no, it'd just be GPIO because these are commons. This would be GPIO, arrow, int spell, whatever you want to set it to. IN, whatever bit you want to change. Yes, because those registers are common to all of the GPIO. Okay? Jason, what's one final? So if I can generate the interrupts all the way out here, is that going to be enough to wake up the processor? What did we talk about on Wednesday, that whole controller that was in the processor? So remember, we had inside the processor, not only, and the reason I make that distinction is because Ben was saying interrupt enable. And you have to enable the interrupt inside the peripheral, but you have to also have the interrupt enabled inside the processor as well. Because if you generate this signal here and it doesn't go out, if it doesn't go out to the processor and the processor doesn't recognize it, nothing is going to happen. So not only do you have to pick what port you want, you have to set rise or fall, you have to enable it in the peripheral, and you have to enable it in the processor. This will be an NVIC function call. So remember I talked about the nested vector interrupt controller. The NVIC controller is what enables interrupts in the processor. And Kira, there's one step I'm missing on here that may not be obvious. Do you have any thought to what that might be? And it goes before this step here. It has to deal with the state of the pin. If I'm going to listen to an interrupt, do I want my pin to be an input or an output? You want it to be an input. So what's not on here and what's not on this diagram is you need to set the pin to input. So there are sort of four major steps for setting up. There are four major steps for setting up inside the controller, but you also have to have the pin as an interrupt. So if you were going to walk through this process, hello computer. If you were going to walk through this process, the entire process for setting this up is pick the pin and port that you want. So PB0. If you pick PB0, that means you're doing interrupt 0. If you pick PC3, that means you're using interrupt 3. Depending on the interrupt or the pin that you pick, you need to make that pin an input. Once you've made it an input, you need to configure SELL or SELH to pick the ports. There's 16 different pins. The lower ones are in the low register, and the upper ones are in the high register. Once you've done that, and again, all this lovely code that you have to write, once that you've done that, you need to pick either rising or falling edge for your interrupt source. If you don't pick rising or falling edge, nothing's going to happen because these are not level triggered interrupts. So there's the rise register or the fall register, and to Michael's point, if I'm modifying interrupt 0, I'm going to change bit 0 in that rise or fall register. Once you've done that, we come down here to this step where we enable the interrupt in the peripheral. There's an IN register, and you're going to want to modify, for this case, bit 0. So to Ben's comment, you'd say GPIO arrow IN and then set bit 0. This is why your read bit, write bit functions that you're writing for the labs, you want to make sure they work and use them over and over. This is going to get really annoying if you have to write brand new code each time. But if you have a write bit function, you just say write bit GPIO-in, 0, and it sets the bit. So you want to use the functions that you're going to build up as much as possible. So in Lab 2, I make some helper functions that you may already have, because you may have written them in the GPIO lab. There are also some helper functions with interrupts. It's worth your time to try to implement those functions. Otherwise, you're going to have long, long lines of code, and you're going to kind of forget what everything does. But really try to use functions to contain and minimize your errors. Final thing that you got to do is once that signal is generated and is going out to the processor, you've got to use the invic call to enable it in the processor. And this is basically the same thing, but as a list. So if you were going to do this in practice and you want to say, well, how the heck do I do all this? If you were going to do PC2, you need to make PC2 an input. How do I make it an input? Look at lecture 2, look at lab 1. That'll tell you how to make it an input. Now you want to enable the external interrupt 2. That means you need to modify the cell register to select port C. You then need to modify rise or fall. Once you've modified rise or fall, this attaches finally this pin to this interrupt. This enables the interrupt, and then the invic calls, which I've copied in the application note, it gives you all of the invic calls, but the ones that you're really just going to use are clear pending and enable. So before you enable an interrupt, you always want to clear any pending flags, because maybe you had some old configuration that was detecting a different event. You don't care about that event now, so you want to clear any flags that might be there, and then go on and actually enable that functionality. So to generate an interrupt, you've got 1, 2, 3, 4, 5, 6 lines of code to do it. You might want to build a function that does this for you. So as part of Lab 2 in the GPIO, I have a function prototype called setExternalInterrupt. What I suggest you do is put each one of these things as a block of code, as a comment, and then write the corresponding line of code. You'll need to do it for an arbitrary pin, but everything is mapped out mathematically so that you should be able to do it for any arbitrary pin. Questions on how to do this, because you're going to need to start doing that on Lab 2. Now, this is pertinent to Lab 2, but this is sort of a general comment on interrupts. You have rising or falling edge detection. So let's say that you enable rising edge interrupts, and you find yourself in myself in an interrupt handler. It's reasonable to conclude that a falling edge triggered that. The one thing that you don't know is how many times, first off, how many times that interrupt has occurred. So if you find yourself in an interrupt handler and you have falling edge detection enabled, does that mean that that interrupt happened once, twice, or 500 times and your processor was really lazy about getting to it? So let's say that you were going to try to measure the frequency of a square wave and you said, well, I'm just going to check every time that falling edge occurs and I'll time that out. If your processor is really slow in responding to those events because either there's a higher priority task or he had interrupts disabled and you miss 5 edges, then you're going to have the period or frequency of that wave off by 5. So there is no, simply being an interrupt handler is not cause enough for you to know how frequently something occurred. In the same way, if you have both rising edge and falling edge detection happening, you don't necessarily know which edge caused you to be in the interrupt handler. You're not able to tell which action happened first. Because there could have been a rising edge and a falling edge, now you're in the interrupt handler. There could have been a falling edge and then a rising edge, and now you're in the interrupt handler. So there's no way to determine the order of the events when you have both on. So if either one is enabled, you'll not get frequency. If both of them are enabled, you cannot determine the order. Now, to sort of prove that out, let's say that you're in an interrupt handler and you say, well, Dr. Forsythe's not making any sense, and so I'm just going to look at the state of the pin, and that will clearly tell me what happened and how I got in this interrupt handler. So imagine if you're looking at falling edge here, boom, you hit a falling edge, you start your interrupt handler, you clear the flag, and then it ends, and you just say to yourself, well, I'm going to measure this pin, and clearly that means it was high, it was low, it was a falling edge. But some of the things that can go wrong in your execution is falling edge occurs, my interrupt becomes active, but I'm really, really slow in detecting and clearing my interrupt flag. So while I'm in this interrupt handler, another falling edge occurs, and then I decide to clear my flag. So if you're trying to count frequency of some events, you're only going to be in this interrupt handler once, but 2 events will have occurred. So this is an argument for why, as soon as you get in an interrupt handler, the first thing you must do is clear that flag. Because unless you clear that flag, another event can occur, and you will miss out on that event, or you will miscount the number of events that occur. All right, it can get even worse. You can try to say, I'm going to count falling edges. Here I go. You're going to have a falling edge. You're going to become active. Oh, but wait, as soon as you became active, you got preempted because someone wanted to stream Fortnite on their processor, and well, that's now on a higher priority. So another interrupt occurs, and another falling edge occurs, but again, you miss that edge. So you can miss it again, not necessarily because you're slow in responding to the flag, but because someone else preempts you. So here, you've missed your second edge because you've been preempted. Sort of the correct operation that you want to have is, as soon as you get the interrupt, you want to clear that flag. So in this example here, that interrupt handler would occur twice. Even though you're inside the interrupt handler and you cleared the flag, as soon as you clear the flag will be reasserted, so you'll leave the interrupt handler and then immediately re-enter the interrupt handler. So this example, you get the interrupt handler once, it ends, and then immediately resumes. So there are 2 edges on this one, and there are 2 pops, 2 instantiations of your interrupt handler. So this is the correct behavior that you want when you're trying to catch multiple events. Again, with the rise and fall events, you may say to yourself, well, I'm going to enable both, and I'm going to just look figure out what the heck happened and what the heck is going on, but you're going to run into the same problems of timing because you're not necessarily going to know what's happening. So let's say that you have rising and falling edge detection enabled, and you say to yourself, well, I'm just going to check the state of the pin, so I'm going to know what happens. So here, if you trigger on this falling edge and you measure here, well, you say, well, I measured a 0, so it must have been a falling edge that triggered me. And then it ends, and you measure it again, and you go, well, gosh, that must have been a falling edge that triggered me. So you might think that this logic works. Except, if you have them both enabled and a falling edge occurs and a rising edge occurs, and you try to measure the state of the pin, you're going to measure a high state. So you're going to think that a rising edge was the first event. The rising edge was not the first event. The falling edge was the first event. So there's no way to determine the order of these two events. It's not like your interrupts have a timestamp on them that tell you what order they came in at. Some systems may have some feature like that tells you the order, but when you look at the state of your interrupts, you're just seeing the current state. You don't know how old they are. Same event could happen where you have a falling edge and a rising edge, and again, you manage that, and you say, well, that was the rising edge is what caused it. And you can go sort of on and on through these actions, and you can, instead of, you can be slow in sampling, maybe you don't clear it fast enough, or again, you can trigger, get preempted, trigger, and then measure the wrong thing. So the fundamental idea here is that if you're detecting both rising or falling edges, you will not be able to determine the order of the events. This is going to matter because you're going to be doing button detection for Lab 2. So Lab 2, one task is to hold down a button, and for as long as you hold down the button, you're going to have to then turn on an LED for that amount of time. You need to know when the falling edge occurs, and then when the rising edge occurs, and time the duration between them. You need to get the order of these events correct. You can't flip them, because then you will measure the wrong amount of time. So, what you want to do is you do not want to enable both of these events at the same time. There's no benefit of having sort of rising or falling edges enabled because you don't care how many times the button was pushed down and released. You care about the whole entire single press. So what you should do is set up your interrupt to detect either whatever edge is supposed to come first. If your button is supposed to always look like that, where it's a falling edge and then a rising edge, enable falling edge first, then in the interrupt handler, change the configuration of the GPIO to then detect a rising edge. Because if the button functions properly, there will always be another edge. So what you want to do, especially for Lab 2, is say, well, I'm going to wait for this falling edge. Cool, I got it. Let me start timing. And I'm going to change my configuration to now I wait for the rising edge. Cool, the rising edge just happened. Let me compare the time between these two events. Ben?
Can you do that in the interrupt?
Yes, you can do that in the interrupt handler. So in the interrupt handler itself, you can do whatever you want. But what you should do is you should stop interrupts. So if you're going to change the configuration of the peripheral while it's running, clear the interrupt handler, clear the interrupt flag, disable the interrupt itself. So timer IEN register, disable the interrupt, change the config, clear anything that may have become pending, re-enable the interrupt. Don't change it inside of NVIC, just change it inside of the peripheral. Because if you change it inside of NVIC, you're going to disable all even or all odd interrupts, and you don't want to do that. So yes, you can change your configuration inside of the interrupt handler. You just need to do it in a safe manner. And the safe manner is to disable interrupts, make all your changes, clear anything that's pending, re-enable the interrupts. And it will function properly. Because being in an interrupt handler is just another function call. There's nothing, no bits are getting set in the flags because you're in a handler. The IF register is off in the peripheral, not inside the processor. So you can try to enable both, and I'm going to tell you it's not going to work, and it's going to be glitchy, and you're going to hate yourself. Travis.
So it becomes glitchy because it doesn't understand which edge is being detected first?
Yes, so let's say on the button, let's say here for the button, you want to measure this duration right here, from falling edge to rising edge. But let's say that I actually want to measure this duration and then this duration. If you mess up and you forget the order and you try to measure, you could end up trying to measure from here to here, which is the wrong duration. So if you say, well, let me measure from here to here, well, that'll give you 1, but then you'll have another edge from here to here, and you're going to lose track of what happened. So your buttons, I think your buttons are idle high. Like when you're looking at that, they're idle high. So the buttons are idle high, so you know for a fact that the falling edge is going to be the first one. Someone's going to hold down the button, and then they're going to release it. So you want to detect a falling edge first and then a rising edge. So you can know nothing's going on with my button, or my button is being held down, and the idea is that while the button is being held down, you are timing that. Then once you have the value of a timer, you then want to launch an LED that runs for that amount of time. That's the idea. Okay? For lab 2, you're going to need to do that exact detection. You're going to need 2 interrupts, you're going to need 2 timers, timer 0, timer 1. You're going to need both interrupt handlers because you have 2 different buttons. So there will be 4 interrupt handlers in the lab, and they are all going to have to interoperate with each other. So button 0, you're just going to click it, and each time you click it, it's going to change its frequency. So he's going to have his own little timer, and that's going to be a pretty easy interaction to get once you figure out how to do the timer. Button 2, where you're holding down button 2, and then you're illuminating an LED for that amount of time, that's tricky. And that's going to cause you're going to have to keep track of the state of your system. You're going to have to keep track of this amount of time. Then you're going to have to feed this time to another timer, and he's going to have to figure out when to turn off the LED. So the first thing I would do is not jump down and write code. The first thing I would do is get out a piece of paper and figure out how you're going to assign your resources. So you've got 2 different functionalities. What's the algorithm that you're going to follow to get this functionality working? You've got 10 days to do it, but my solution was 300 lines, and mine was pretty efficient, meaning I had a lot of functions doing a lot of things for me. So really make sure you get on this now, and I'm going to finish up in a second. We'll have the rest of the class to do it. But really make sure you get on this stuff now such that you're not sitting here Tuesday night or a week from now trying to get it working. All right. So again, don't enable both events because you will lose the ability to distinguish between them. Again, overall conclusions about interrupts. They have to be enabled. You have to service them with the processor. You have to change the configuration inside the processor. The interrupts on the GPIO, the most important stuff that you need to know is you need to understand, 1, why you have to do all this, why you have to go through these 6 steps, and then you need to understand how to do all these things. So how do you make this as an input? We covered that. You have to look up this register and pick the right port. You know how to modify registers. You need to set rising or falling edge. You know how to do that. You need to clear the flags before you enable it. And you need to clear the flags to make sure that you don't get stuck with old interrupts. You then need to enable the correct interrupt in this register. So if you were going to change something, then I would do this in reverse. I would disable this interrupt. I would clear the flags. I would change my settings. I would then clear the flags again for funs and giggles. And then here, I would re-enable my interrupt. And I would have said shits and giggles, but it's recording me and I don't care now. So never necessarily do 6, because that disables all the odd and all You don't want to do that. But you want to walk down this line to set up your stuff. If you're going to change it, go backwards. And then go back again. You want to do these in a logical, reasonable order. And honestly, the most important are steps 4 and 5 because you don't want spurious interrupts and you want to make sure the interrupt is enabled. Okay? I will upload these. You will have them. Another important thing is to understand. So, I tell you these things here about why you can't determine frequency and why you can't determine order. And I want you to have a deeper understanding of why that occurs. Hence, all of these examples here showing all the bad ways that this can happen. The main point about interrupts is to get them set up and to let them run and try to make it as simple as possible. Don't do big complex calls and interrupts. Don't call too many other functions. Try to make your life as easy as possible. I would actually probably have I'd have very few function calls in your interrupt because you want to make sure that they're short-lived. With that, I'll put this online and let me show you lab 2.